And in this video, what I'm just giving you is just kind of the expected output for homework 9. And this is spring 2023. So what I'm doing here is running my code in an IDE. I'll mention this in class about how to do this, but you can also do this in notebooks, but on my computer, animations don't work too well on a notebook, so I'm running it within a text editor. And so here the first problem is what I want you to do is simulate, and it's running now the code, a single ball kind of bouncing around in kind of a closed container. So the ball kind of collides against the walls of the container. It's a single ball. It has a radius of 50, and I initially placed it in the center of the surface, and then I gave it a random initial velocity of magnitude 1. And in the homework, in the file, I kind of explain how that was calculated, but this is kind of your first problem, a single ball. Let me get rid of this. Let me go to the second problem. And then here I'm running kind of a similar problem where we're extending it, and now we have two balls. So these two balls can both kind of collide against the surface. So I have a red and blue ball, again, radius of 50. And if we let this run long enough, they will eventually also collide with one another, hopefully. It's kind of random. Now they're going to bump against each other, exchange momentum, and move in the opposite direction. The equations are given in your homework for the simulation. So start with problem 1, get the balls to bounce off the wall, and then work on getting the collision between the two balls. The last problem is kind of extending problem 2. So rather than just doing two balls, we're going to do an arbitrary number. And in this case, we're going to do 50 balls, each with radius 10. I run it, and then we have lots of balls kind of colliding against one another. So this is kind of like an ideal gas or at least hard sphere collision. So this is used a lot to model different kinds of gases and liquids. And so we have all the different balls colliding against one another and running it in using Pygame. So again, the details in the document, but this is just kind of giving you what the expected output is for your homework assignment. You can do it from the command line or in an IDE, what I'm using here, or you can do it if it works well for you in a notebook. It's just for whatever reason, I have a hard time exiting out of Pygame when I'm using kind of a notebook, so I decided to use an IDE to run this. So these are just kind of the expected outputs. Details are in the homework assignments, and with that, I'll stop. And thank you.